Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. Welcome to AP Chemistry Lecture 4. Today we will continue on Chapter 1, Atomic Structure and Properties. Let us start with composition of mixtures. Which of the following mixtures is not a homogeneous mixture? Wine, coffee, tea are homogeneous. Oil and vinegar, immiscible liquids. A table salt solution, homogeneous. So the answer is D. Since a homogeneous mixture is a uniform mixture of two or more components that appears uniform throughout. The oil and vinegar mixture could not appear uniform, and thus it is a heterogeneous mixture. Well, what differentiates a homogeneous mixture from pure substance? A homogeneous mixture is uniform throughout. The composition of pure substance is fixed. A pure substance is always a compound, while a mixture can be elements or compounds. A pure substance can be separated into elements by physical means. A mixture has a defined composition. Well, the answer is B. The composition of pure substance is fixed, while mixture you can change the concentration of A and B. So the composition of pure substance is fixed. A heterogeneous mixture is a mixture of two or more components that do not appear uniform throughout. A pure substance contains only one component that has a fixed composition. So here defined that the pure substance contains only one component that has a fixed composition. The answer is B. Separation of mixtures. We can separate liquid mixtures by distillation, by evaporating the most volatile substance first, usually the one with lowest boiling point. So the important thing to know that it separates based on differences in boiling point. If we have component A and B here, liquids, we heat, transfer them to gases, so the one with low boiling point will get into the gas phase first, then condensed with a condenser, so we get A and B separated. Here we have distilling flask, we have here what we call distilling head, we can have here a stopper or thermometer to measure the boiling point. Here we have condenser, then we have receiving head and receiving flask. We can separate mixtures by filtration. If we have solid and liquid, filtration separates mixture by using mesh to separate solid from liquids. However, this only works with heterogeneous mixture, where the solid will not be soluble in the liquid. So we have here liquid and insoluble solid. We have here filter paper, and we get the liquid, the filtrate in here, and we get the solid, insoluble solid will be in here. Chromatography. Chromatography is based on the principle where molecules in mixture applied onto the surface or into the solid and fluid stationary phase is separating from each other while moving with the aid of mobile phase. The factors effective on this separation process include molecular characteristics related to adsorption liquid solid or gas solid, partition liquid solid, and affinity or differences among their molecular weights. Here we are going to show that different type of chromatography, three different types. Thin layer chromatography, when we have silica gel as stationary phase or aluminum oxide, based it on a piece of glass or plastic or aluminum. We spot the mixture at the end and then elute the mixture using solvent or solvents mixture. It moves up, the solvent moves up, okay, and separate the components. Thin layer chromatography. Column chromatography, when we have to fill the column with, and again, stationary phase like silica gel. We load the sample at the top and then elute with a solvent with mobile phase. And again, the mixture will separate. The upper one will be stronger interaction, it's moving slowly, and this one will be a weaker interaction with the stationary phase. Also, we have gas chromatography for volatile mixtures. We inject the sample, turn into vapor. Here we have column backed with stationary phase. Again, the components will be moving with different speed on that stationary phase and gets out and detected. A student dissolves some sodium chloride in water and wants to recover it. Which technique should he or she use? Crystallization, filtration, centrifugation, evaporation, distillation. Well, sodium chloride in water gives homogeneous mixture, so we cannot use the filtration. Crystallization, we can evaporate water. We would like to recover the water and sodium chloride. Crystallization means that we are going to lose a huge amount of water, depend on the concentration, of course. And finally, we get water, but we get the water with sodium chloride, so it's not really separation. Centrifugation, again, it is homogeneous mixture. If we evaporate, we get the sodium chloride, but we lose water. So the answer is distillation. A mixture of sand and sodium chloride is commonly known as rock salt. Sand insoluble in water and sodium chloride is soluble in water. Which of the following shows the correct order needed to separate sodium chloride from rock salt? Well, dissolve in water, then filtration, followed by crystallization or evaporation. Or filtration, dissolution in water, distillation. Or filtration, crystallization, dissolution in water, crystallization, dissolution in water, filtration, dissolution in water, crystallization, and then filtration. Well, the answer is A, dissolution in water, so we get sodium chloride soluble in water in solution, and sand is insoluble, so then we filter, separate the sand from the sodium chloride solution, then evaporation or crystallization to get the sodium chloride. See you next lecture.